came here, he brought me a Hot Rod
Deluxe.
And it's buzzing, right?
Yeah, it just makes a really loud buzz sound.
Yeah.
Don't know what's wrong with it.
But it was here, what, like 2 years ago maybe? And I think I soldered some resistors on the board, didn't I?
No, that was a different one. That was a different one.
Well, that's good. That means it's not a warranty job.
This is not a warranty job.
Ah, okay. So you recently acquired this one. Did it work for a while?
Yeah. No, I don't know the history of it. I don't know the history of it.
Okay. All right. So everybody can see then, this is obviously not a staged performance, right?
Right. I just literally brought this in right now.
Yeah. So these are the main violators normally. Super spray. Yeah, of course. So what happens to these filter caps is they leak. I don't see any leakage on them. So that's good. All right, man, let's hear the buzz. One of your output tubes here, the logo on there is a lot darker than this one.
Okay.
So it could be like a bias issue. I always have my
stand back
tapper ready. There we go. Is that good, huh, when she goes? Yeah. Whoa!
Yeah.
Man! Whoa, look at, see that? Whoa, there's smoke.
Whoa, I just saw that too. I don't know where that came from.
You know what that really sounded like to me? It sounded like a shorted output transformer. It's probably...
Oh, smelled it too.
Oh yeah. How long did you have it on?
Just like that, just a second, and then turned it right off.
Yeah. Yeah, it really sounds like a shorted output transformer. Because these guys weren't even warmed up. So what we're going to do is we're going to pull your output tubes right out. We're going to do it again.
Hold on.
Quickly.
Can you see this? Are you seeing this?
Because what we're going to do now, since the output tubes aren't in there, there's no path for the high voltage to go through that output transformer.
Okay.
But if we hear it, it's a shorted output transformer. Yep. That's why the output transformer's smoking. Internally, the high voltage that's going to the windings has shorted. So it's probably shorting, it's arcing to ground inside of the transformer. So pulling out the output tubes, I took away the current path. But there's still smoke and noise. There's nothing left but the high voltage going through the output transformer. So that's not good, man. So, you know, but this is a perfect candidate to turn into the amp of your dreams. Because look, you got the speaker, right? You got a 12-inch speaker.
Yeah.
I'll put that circuit in there. We put a new control panel, get rid of all that craziness, give you a nice straightforward amp. And then you don't have to deal with these circus boards.
Circus boards.
Circus boards, right. Yeah. We can get a new output transformer and get this thing running as is, but they don't have longevity. They don't survive. You'll have the same back here every year.
Really?
Yeah. Yep. Hate to say it, Fender, but I don't like this design. So the first thing I like to do is pull all that out and put it in a hardwired board and make it live for 30 years.
I'm okay for that. I'm okay with that.
All right, man. All right, so we just made a grand discovery, and I've got to share this with you guys because I have never seen this before. It's really good. So we thought, okay, let's go ahead and buzz out the primary of the output transformer. So here is your high voltage tap, and then we go to each side. So there's one side. Let's scale down so you get a better look here. So we're seeing about 180 ohms on that side. Go to the other side. And you see it's about 1,000 ohms. So there's almost an 800 ohm difference. Now when we were checking that earlier, there was like a 600 ohm difference. So you see the resistance is moving, okay? It's because whatever's carboned up in that transformer is changing. But here's the alarming part. So I thought, well, let's measure from one of the speaker outputs, which is on the secondary winding. It should be totally isolated from the primary, right? If we go there and take a look, look at there. I've got about 467K ohms. You may think, well, that's pretty high and that's okay, but no, it should be infinite. It's 2 coils, right? So you've got a primary coil with a center tap, and then you got your secondary, which is your 8 ohm that goes to your speaker. There should be no DC present on the speakers. It's there to protect it and to step it down, right? So what's happening, guys, is the high voltage is going right into the speaker. But luckily, when we measured the speaker coil, this is also broken off, it's really nice. We still have 7.3 ohms, so it didn't fry the speaker. So now what my question is, you know that smoke we saw? I don't think it came out of the transformer. I think it came out of the cone of the speaker. It may be okay, it may... I'm not hearing anything crunchy, so it's probably still usable. So we caught it at the right time. Wow, that's good stuff, man. All right, so Joaquin and I have been discussing this for a while. We didn't have to have all that on video there. You guys would have went nuts watching as we went back and forth trying to figure out what to do. So what we've agreed on is he realizes that this circuit board and this technology is unreliable, and even if I fixed it, he'd probably be back getting it fixed again, okay? So what we've ended up doing is we're going to remove the circus boards, okay? And to give you guys a visual, we're going to drop in a Princeton AA1164 circuit. So he actually is going to get my last classic tone power transformer made in Chicago, just like you, right? Yeah. And we're going to use the Hammond output transformer, add the reverb circuit. So pretty much all we're going to use out of this amp would be the cabinet, the speaker, chassis, and knobs. That's it. Everything else is out of there. And we're going to reconfigure this as a Princeton, and then he's going to get his own logo or name, whatever you want to put on it.
Maybe.
Yeah. So I'll make the custom overlay. So things that we're not going to use will be eliminated. You'll never even know they were there. And you'll have your custom boutique amp that you always wanted. And you don't have to pay like $4,000 for a Princeton, man.
And I'll be back to test it out.
Yeah.
Too.
Yeah. And if he doesn't like it, I guess I'll put it up for sale.
Yeah,
I'll just
that's
take
right.
your logo off, pop mine on. Deal?
Yep.
All right, man.